Hi, I'm Dave, and I am super geeked because I'm sitting in my lab with a brand new MDO 3104 oscilloscope. I know what a lot of you are thinking, those MDO series, it's not that big a deal, it's just, a fancy wrapper around the same scope, and to be honest, I thought the same thing, but I took a closer look and I thought it would be a good time to upgrade to not only a new scope, but a better scope with a little bit more capability. To that end, I'm going to spend the next couple months going through both the MDO and my trusty TDS 2024B scope and compare how they perform in my normal tasks, what the new scope capabilities are, and what are the things that I am really excited to have as another piece of equipment in my lab. So let's get my stupid face off the screen so we can take a look at the tech and see what it can do. Okay, so what do we do when we get new equipment? We turn it on. First thing, always turn it on. Immediately you can see the obvious differences. The screen is very different on both of these. And the indicator lights, these are all lit buttons where these little LEDs are here. So I think the user interface is a little bit more friendly. It's easier to see, it's easier to do things. And I don't know, I just like big screens. Bigger screens is better screens. The other thing that I want to point out is the similarities. So we've got the 4 channels here, the 4 channels here, vertical, vertical, trigger menu up here, horizontal, horizontal. All the standard scope functions are pretty consistent. I'm actually looking forward to the fact that I should be able to run both scopes at the same time, or at least with no extra training or manuals, and get the job done quickly. I love quick learning curves and getting straight to the answer I'm after. I'm going to start this little exploration in doing something that everybody should do when they get a new scope. I don't know if they do or not, but compensating a probe is really quite important. Let's take a look at my channel 2 probe here. And bring that down. Whoa, that definitely needs compensated. I'm going to change the trigger to source on channel 2. Wow, that definitely needs compensated. And then on the new scope, we can get connected to the probe compensation signal. That doesn't look so bad. Let's again change the trigger to channel 2. Okay. Alright. Put the trigger. There we go. Okay. So like I said, it's pretty easy to use both of these scopes. I don't have any experience with the MDO, and yet I'm able to quickly get it set up with no problem. On the 2024, you got to compensate it with this little screwdriver, and we come in here and we adjust it manually. No big deal. Dial it in. It's got to be plastic, but it works. Okay, fine. Same way we've been doing scope probe compensation for years. With this, it's got a little bit more fancy approach. You can go into, that's not what I want. Probe setup. Here we are. Compensate probe. Right now it says compensation status default. So if I go compensate probe to OK, compensate it. Probably a bunch of stuff I should read, but I'm not gonna. There we go. Compensate. It says compensation status compensated. We are all set. So I can get back to this. It's a nice square wave. It doesn't look very different. It was probably, pretty close when we got it. But I've got a compensated probe, and what's really neat is that these probes come with their serial number because it's a smart probe. It knows what's going on in there. So if I was to unplug it and plug it into channel 4, channel 3, it would know how to compensate it and bring it right back in. So pretty neat feature. Not anything that would sell a scope, but it makes it easier to share equipment and know that you've got something that's working. So for the first circuit that we're going to be looking at today, I decided to go with a Adafruit Minty Boost. This is a favorite of Blue Stamp engineering students everywhere, and it's a great way to look at a switching circuit, which comes up all the time in electrical engineering, especially analog engineering when you're trying to build a DC to DC converter. So I've got channel 1 of my TDS 2024, and I've got channel 1 of my MDO 3104. Let's take a look at how it looks at the output and what things we can notice as differences. To get started, we're going to look at, we've got 5 volts here at the output, and here we've got 5 volts. Great. Let's do a quick measure. Peak to peak, let's see. What do we want? Instead of peak to peak, we want, let's do average. Come on, there we go, mean. 5.09 volts, no big deal. And then on the 3104, let's go measure, and add measurement, source channel 1, measurement, type. I want, what was it? It was average or mean. There's a little bit more here, and these descriptions are nice, but you know, you shouldn't be measuring things if you don't know what they are. Okay. Menu off, and then I've got a mean of 4.96. I don't know which one is right, but nobody buys oscilloscopes to sit there and measure DC voltages. That's fine. Maybe we will switch it up so we can take a close look at the switching noise that occurs. So channel 1, we're going to switch this to AC coupling, and then we're going to zoom way in on the x-axis. Wow, maybe not that far. Okay, let's take a look at the trigger menu. Source, trigger, bring it around to channel 1. Good. And bring the level down. Hopefully we can find something. Okay. There we go. Getting some noise here. Okay, switching noise, great. So we can see it here, or we can zoom out and we can see a bunch of random noise happening. No problem. Let's take a look at it close in so we can see the actual switching noise. Cool. If we want to go all the way in, we can see the ringing. Great. This is why people don't buy new scopes, is because it works. You can get the job done. Okay, so the same thing over here. Channel 1, I'm going to want to go AC coupling. And again, I've never done any of this stuff before, so there's no manuals or me knowing anything that you guys don't know. Okay, immediately I can already see more noise, probably because it's a faster scope and because it's got a bigger screen. And then let's go trigger menu, source on channel 1. Good. And we'll bring this level down to here. Again, we can see a little peak here. It's tough to see with it right in the middle, but if I move it to the side, you can see it. There's that peak. Let's take a closer look. Let's get all the way in. And there it is. Same story as before. Same thing on either screen. If I want to go in and look at the ringing, here I am with the ringing. Works great. Just like the 2024. Awesome. And if I want to zoom back out, let's see if I can see some other noise. Yeah, here we go. So I can see peaks here and peaks here, and I'm definitely taking advantage here of the bigger screen and the different way of seeing things. Now I'm just going to stop right here because I've heard about the zoom function, and I've never used it before. Let's check it out. So I can zoom in on, oh, that's kind of neat. So if I want to, I can zoom in on this, and this shows me at the original place I was. It's got some panning action. That's kind of cool. But it doesn't look like I can zoom all the way in to see like the ringing. We'll take a closer look at that later, but looks like, there we go. If I zoom in further, I can start to see the ringing. And so we've got a zoom of, 5x or 10x or whatever, and that's about its limit. Okay, great. So looking at noise on a switching power supply works great on both. A couple extra features on the 3104. I don't know if it's worth it or if it's something that somebody would want to chase after a new scope for. The next circuit we're going to look at is a voice changer. This is another favorite starter project at Blue Stamp, and the students oftentimes have to troubleshoot it with an oscilloscope. So let's take a look at channel 1 right on the input from the microphone and channel 2 on the output to the speaker. Both scopes have the same connections. Let's say we wanted to test the impulse of a signal going through this. Now you can see on both of these scopes, they're both running, they're both picking up my audio for my voice, and actually they both look pretty good. This scope looks like it's picking everything up just the same as this scope. But what if we wanted to check an impulse response? For instance, a snapping of the fingers. How do they look on the different screens? And the best way to catch these is on a single sequence trigger. So I know how to do it with, well, I'm not sure how to do it with this one. Let's check it out. Single, here we go. One button, and then here, single. Got it. That actually was really easy. Same here as it's always been on Tek scopes. You press a single sequence button and it captures it. Alright, let's try and do another impulse test. Oh, that's a good one. You can see the input and the output signal with the delay. That looks great. So the voice changer's not really doing much except for maybe adding a little distortion. That's awesome. Now let's look at what we can do to get the thumb drive to save this stuff. So first, I know for my 2024 that it takes a while for it to realize who's there. Let's check on the MDO. Now that we have these things plugged in, let's take a look at how we can save an image. So I can hit save, and I've already got this button programmed to save an image, and it's going to sit there and chug along for a while because its access to the USB drive is slower than molasses. Over here, I can go menu. I want to make sure, yeah, assign save to image, good. So if I was to hit save, just like on that one, there it goes instantly. Tek 0001, I guess. That popped up quickly though. That's unfortunate. Couldn't really get that down. Okay, what about the waveform? Let's say we want to save the waveform. I'm going to save all displayed waveforms, good. Destination, I'm going to go, all destination, I'm going to go down here to file. I want to save it there, and I'm going to hit OK save. Great. So I've got all the waveforms in like 2 seconds. Good deal. Now here, it's a little bit more complicated. You have to go save recall, and then we go over here to save waveform, and we get to pick save to file, and our channel 1, and we're going to do a CSV file. Great. Save. More time, sitting there waiting for the USB stick. Okay, so there's one, and then I actually have to go in here and do a 2 as well for channel 2. So I can't save them all. I'm sure this is going to come up as 2 CSV files, whereas here it should probably come up as 1 file with 2 columns. I now have all of the different files that I saved from both scopes. The 2024 are these 4 files, and the 3104 are these 3. So my favorite thing is to look at the images. Let's take a look at this first one that I saved. Cool. Second one that I saved, also cool. I don't really have anything special to say about it. Everybody knows how to take scope traces. And then let's take a look at this. Here's one that I took, and a second one that I took. Great. So just like looking at the screen, nothing too special. The only thing I'll note is no additional resolution on this file. It's 800 by 480, which is a representation of its screen. Same to this file is 640 by 480, which is the same as the screen. Not a problem, but you know, it's not like it's a super nice image that you get. Now there is a difference between the 2024. You have to save each channel individually. I've opened them up here. This is channel 1. It gives you the information over here for channel 1, and here's the data with time and voltage. And then there's a similar setup for channel 2. It says channel 2 here, and again, time and voltage. No big deal. We can look at what the 3104 produces, where we have channel 1 and channel 2. So we got channel 1, channel 2, and time. It's nice they put the labels in here, and you can probably get to a graph situation faster here than you would with trying to discern this data on the 2024. Otherwise, it looks great. Pulling data in from these scopes is easy, and I don't have any complaints. There you have it. The quick and dirty test of these scopes. I did a couple circuits, took a look at how the triggering works, played around with the knobs, and really just gave it the 70% test. Most of the stuff you're going to do consists of what I just did, and it turns out that my trusty scope works great for all that. Now, we haven't even gotten into half of what this new scope can do, and I'm going to start doing that with my next video and my next article, where we're going to dive into all the other neat stuff that they added to the scope. For now, I'm happy here, but we'll get a little more exciting with the next one. Stay tuned, and I'll see you then.